Today we're starting chapter 6. Chapter 6 talks about ratios, proportions, and probabilities. 6.1 talks about ratios and rates, but today we're just going to talk about ratios. So let's first go ahead and define what a ratio is. So you have a blank there on your notes. Let's go ahead and fill this in. A ratio uses division to compare two quantities. So we're going to have one number divided by a number. Now right under that it says there's 3 ways to write a ratio. The first way, and we're going to use A and B, is I can write A colon B. And we read this ratio as A to B. The second way we can write that same ratio is if I say it A to B, I can actually write out that word to. So I can say A to B. And the last way, which is probably going to be the most handy way, is writing them as a fraction. So A over B. Because remember, just right up there, we said it ratio uses division to compare two quantities. And a fraction is just a fancy division problem. So I can write it as A over B. And we're going to use that last idea for most of what we're doing today. So the first thing is we're going to look at some ratios. We first want to say if it's in simplest form. And if it's not, we're going to go ahead and put it in simplest form. So first example, let's look at the ratio 6 to 9. Now it might be hard to tell whether that's in simplest form or not, so what I like to do, since I can write a ratio 3 ways, I like to go ahead and write them as a fraction. And if I look at 6 over 9, you're basically asking if that is a fraction simplest form. Okay, well 6 over 9 is not in simplest form, so this ratio is not in simplest form because I know that I can divide out of 3 from both 6 and 9, so that ratio in simplest form would be 2 to 3. And you could write this as 2 colon 3, 2 to 3, or 2 over 3. They all represent the same ratio. Any one of them is acceptable. Okay, let's look at the next one. Let's look at 25 to 12. Okay, this time if I write this as a fraction, you may notice that it's actually an improper fraction, and you might be tempted to write it as a mixed number. If we're talking about ratios, we do not want to write them as a mixed number, because if I change this into a mixed number, it would be 2 and 1/12. Okay, well 2 and 1/12 is not we're not dividing two numbers, so we do not want to change them into mixed numbers. We want to leave them as improper fractions, but I do need to check if there's anything that my numerator and my denominator have in common, and if you think about 25 and 12, they don't have anything in common. So this is already in simplest form, so we're going to write yes. Okay, next one. If I have 51 to 12. Okay, well this one is already as a fraction, so now I just need to look and see if 51 and 12 have anything in common. Now, 51 is kind of a tricky number because it kind of looks like a prime number, but if you start dividing things out, you'll find out that it is actually divisible by 3. So if I divide out a 3 from my numerator and my denominator, I would get 17 over 4. So it was not in simplest form, and my simplified ratio is 17 to 4. Okay, this last one I want you to try on your own. I want you to try 54 to 9. So pause the video, put that ratio in simplest form if it's not already. Okay, whenever you are looking at 54 to 9, you should notice that it's not in simplest form because you can divide out a 9 from both your numerator and your denominator. Your simplified ratio should look like 6 to 1, which you can write it any of those 3 ways. Okay, the last thing that we're going to do today is we're going to order ratios from least to greatest, which is something that you already know how to do. It just looks a little different. So for the first example, let's look at 2 to 9, 1 to 7, 7 to 28, 2 to 6, and 3 to 10. Now remember, just as we were doing in the examples above, I can write a ratio as a fraction, so that's the first thing I'm going to do is I'm going to write 2 to 9, 1 to 7, 7 over 28 already is as a fraction. 2 over 6, and 3 over 10. Now I have 5 fractions that I need to order from least to greatest, and we already know how to do this. May just need a little bit of a reminder. There's a couple ways we can order fractions. We could find a common denominator, but if you look at 9, 7, 28, 6, and 10, they don't really have a nice small common denominator. So the easiest way I find to order fractions from least to greatest is to change them all to decimals and compare them that way. So let's start with 2 to 9. If I want to change 2 over 9 to a decimal, I'm going to take 2, divide it by 9. Okay, well, 9 will go into 22 times, and it kind of looks like I'm going to have a repeating 2. So 2 over 9 is the same thing as 0.2 repeating. Okay, let's do the same thing with 1 to 7. We're going to take 1, divide it by 7. 7 will go into 10 one time with 3 left over. Okay, well, 7 will go into 34 times, and with 2 left over. 7 will go into 22 times, and I'm going to go ahead and stop right there, and I'm just going to say it's pretty close to 0.14. It's obviously not exact, but we're just kind of looking for something in a close estimate. That way I can just order them. Okay, well, let's look at 7 to 28. Now, what you may notice with 7 to 28 is I can divide out a 7 from both my numerator and my denominator. When I do that, I get 1 over 4, which is a common fraction because I know that 1 over 4 is the same thing as 0.25. Okay, you can do the same thing with 2 over 6. If I divide out a 2 from both my numerator and my denominator, I get 1 over 3. And if you either divide out 1 over 3 or you just know what 1 over 3 is, 1 over 3 is 0.3 repeating. And last one, if I have 3 over 10, we say that as 3/10. So it is just 3/10. Okay, now I have 5 decimals that I need to order from least to greatest. So if you look at all your decimals, the smallest decimal is 0.14. But we're not going to write 0.14. We're going to write my original ratio. So my smallest ratio is 1 to 7. My next smallest is 0.2 repeating. So 2 to 9. Okay, after that we have 0.25. So I have 7 over 28, and then I'm left with 0.3 repeating and just 0.3, but remember 0.3 repeating is 0.33333, and 0.3 is 0.300, so it means 0.3 comes next, so 3 over 10, and then finally I have 2 to 6. Okay, I'm going to have you guys do this next one. I want you to order these ratios from least to greatest. 1 to 3, 2 to 8, 5 to 18, 7 to 20, and 9 to 25. So pause the video, turn them all into decimals, and go ahead and order them from least to greatest. Okay, when you took your ratios and put them in order from least to greatest, you should have ended up with 2 over 8 is the smallest, 5 over 18, then 1 to 3, 7 to 20, and then 9 over 25. If you got one mixed up here or there along the way, I do have my decimal approximations written underneath, and then a little bit of my work shown below. So